We spend billions of dollars launching rockets into the vacuum of space, mapping the craters of the moon and the dusty plains of Mars. Yet when we dive into our own oceans, we are essentially flying blind. 80% of the global seafloor remains unmapped, unseen by human eyes. The reason for this is simple. Physics descent. Just a few 100 meters and sunlight vanishes. Go deeper and the weight of the water creates a crushing pressure that can implode engineered steel. It is a hostile environment that restricts our physical presence. Because we can't observe this world directly, we hit this sensory threshold. We are forced to rely on proxy senses, dropping microphones called hydrophones into the dark or bouncing sound waves off the bottom using sonar. We are trying to understand this world by listening through the floorboards. When you can only perceive an environment through fragmented audio clips and low-resolution echoes, the data is bound to be confusing. These technical filters have caught glimpses of anomalies in geometry and acoustics that our current models struggle to classify. To monitor this darkness, researchers deploy networks of deep-sea hydrophones. These underwater microphones record acoustic signatures across entire ocean basins, tracking submarines, shifting tectonic plates, and marine life. In 1997, hydrophones recorded an ultra-low-frequency sound known as the Bloop across 3,000 miles of the Pacific. It resembled marine animal calls, but the math was impossible. To produce that volume, an entity would have to dwarf a blue whale. Over a decade later, the official consensus shifted. The Bloop was likely a massive ice quake. Chunks of ice splitting off or scraping the seafloor can create underwater sonic booms that mimic biological signatures. But other audio anomalies lack such geological parallels. Coastal communities have reported the hum, a persistent low-frequency resonance vibrating through bedrock. It has no clear industrial origin, yet it remains an inescapable presence for those who hear it. Water is incredibly efficient at carrying sound. The ocean acts as a hyperconductive chamber, transmitting evidence of massive events across thousands of miles. Even if we can't see the source, the acoustic data proves that something is moving in the dark. When researchers want to visualize the terrain, they switch from passive listening to active sonar. By pinging sound waves off the seafloor, they can map topographies that sunlight will never reach. This technology has revealed geometries that don't match standard geological patterns. We found miles of perfectly straight tracks carved into the seabed, and long lines of identical rectangular holes punched into the sediment. This brings us to the Baltic Sea anomaly. In 2011, sonar revealed a 60-meter circular structure with sharp staircase-like formations. When the expedition team returned, they encountered equipment failures directly over the anomaly, their satellite. Phones, GPS, and monitors immediately cut out. The INS Dakar was an Israeli submarine that vanished in 1968. It was one of 4 military submarines to disappear into the abyss in a 4-month span, leaving no distress signals and no wreckage. These unexplained incidents highlight the extreme difficulty maintaining any kind of sustained human presence in the deep. Between the physical pressures and unexplained technical interference, the abyss functions as a vault that disables our ability to observe it, to figure out what actually lives down there. Marine biologists have started using environmental DNA, or eDNA, by sequencing the genetic material left behind in the water column. They can identify creatures they have never actually seen. This has revealed a massive gap in our record. Researchers frequently pull eugenomic dark matter genetic codes floating in the water that match no known organism in our databases. Researchers often find themselves dissecting massive creatures like this large. White squid in the crushing depths evolution favors extreme adaptations, driving abyssal gigantism to produce massive predators optimized for darkness. This is Turritopsis dohrnii, a translucent organism known as the immortal jellyfish. When threatened by physical damage, it can reverse cellular age, reverting back to a polyp and resetting its life cycle indefinitely. These traits suggest a biological path optimized for the deep sea, with the standard constraints of aging and growth no longer apply. Despite centuries of seafaring, we have only mapped about 5% of the seafloor at a resolution that can identify these anomalies. The rest of the ocean remains a pressurized vault of the unknown. We have spent decades scanning the stars for signs of an unfamiliar presence, yet a highly evolved world thrives beneath us in our own shadows. The mystery we are looking for exists just a few miles beneath our hull. We are sharing a planet with an unmapped, evolving world that we are physically and technologically unequipped to face. Our cameras fail, our sonar returns impossible shapes, and our DNA pulls empty profiles while we continue to watch the skies. The deep ocean is watching us,